All right, so the end behavior, the number of turning points, along with the zeros of a polynomial function is going to allow us to graph polynomial functions. So to find the zeros of a polynomial function or of a polynomial p, we just have to factor and then use the zero product property. So if you recall from college algebra when we factored quadratics, so if I have a polynomial of degree 2, x squared plus x minus 6, we factor p, so we get p of x, but two numbers multiplied together give me -6, and added together, -2 plus 3 give me 1. And then from this factored form, we can easily see that 2 is a zero of p, and also when I set x plus 3 equals 0, I get that x equals -3. So this is the zero product property. So I have that 2 is a 0 and -3 is a 0. And then a couple of terminology in here. If 2 is a 0 of the polynomial p of x, then we say that x equals 2 is a solution to the equation x squared plus x minus 6 equals 0. It's a solution or a root. So these are some things that are used interchangeably: zeros, solution, roots, x-intercepts. And then x minus 2 is a factor, because when we factor the polynomial, we write it as a product of factors. And also x plus 3 is a factor. And then we also can say that 2 is an x-intercept of the graph of 3 of p, and also -3 is an x-intercept. All right, so this is just a quadratic. -3 is an x-intercept, and 2, and then the y is at -6. So it looks something like this: -3 and 2. So now, similarly for polynomial functions, now the degree can be 3 or 4 or 5 and higher. If we have it in factored form, then we can know exactly where the x-intercepts are or the zeros are, okay? But sometimes when we factor a polynomial, there are factors that appear more than once. For example, you can have a polynomial that looks like this: x plus 1 squared times x minus 2 times x minus 1 cubed. And you notice in here that the factor x plus 1 appears twice. So obviously this has to be different than if it was just x plus 1 times x minus 2 times x minus 1. Because the degree now, when I have x plus 1 squared, if I FOIL this, I'll get an x squared in here times an x times, if I FOIL this, I'll get an x cubed. So the degree of this is 6, okay? So the fact that the factors are repeated basically means we're going up in degree. So when that happens, we say that it's corresponding 0. So for the case of x plus 1, if x plus 1 is a factor, the 0, x equals -1, we say that it has multiplicity 2. So because of this 2 right here. Similarly, the 0x equals 1 from this factor right here has a multiplicity 3 because the factor is raised to the 3rd power. So obviously the shapes of the graphs around zeros with even or odd multiplicity, so this one is an even multiplicity, this is an odd multiplicity, they're going to look different. So when we're going to graph these functions, we're going to have to keep in mind that if the multiplicity, if c is a 0 of p with multiplicity m, so that means that I have a factor like this, x minus c to the m, right? If c is a 0, x minus c is a factor, and if it's a multiplicity m, that means that the factor is raised to the mth power. So if m is odd and m is greater than 1, then the zero, the shape of the graph around that zero is going to be like this, or like this, depending on where the graph comes from. Does it come from down below, or does it come from up above? So it's going to cross the x-axis, but it's going to have that flatness in here. Opposed to when the multiplicity was just equal to 1, if the multiplicity is just equal to 1, it straight up crosses like this, right? Because I can think about p of x equals x minus 2. I can think of this as multiplicity 1. So if the multiplicity is 1, it just straight up crosses it. Now, if the multiplicity is even, it does not cross the x-axis. It's still an x-intercept, but it doesn't cross over. It just touches it like that, just like a parabola. Okay, so now we have all the tools to graph polynomial functions. We know how to get the zeros. We're going to need to factor, and we know that the shape of the graph around the zeros with even or odd multiplicities are going to look like this. So let's practice.